Okay, in 7.4, we introduced the other trigonometric functions. So previously, we had already seen when we were given a terminal point, a point on the unit circle, we could identify that the x value there was going to be cosine, and our y value was going to be sine. So just kind of writing that out here. So if we want to keep that in mind, I think we had already talked a little bit about tangent as well, that if tangent is defined to be y over x, and our y value is represented by sine, while our x value is represented by cosine, we can represent tangent as sine over cosine. And that's kind of a nice identity to know about as we move forward with these. All right, so if we're given a terminal point, we can locate cosine and sine just based on the ordered pair, the values given here. And then what we can do is we can set them up into this fraction with sine over cosine. The other three of these, cosecant, secant, and cotangent, are really just reciprocals of those first three. So meaning if we have a fraction for sine, we can invert it, flip it upside down, and we can get cosecant to go along with it. Let's jump right into a couple of these and take a look if we're given a terminal point, a point on the unit circle, negative square root of 3 over 2, comma 1/2. Let's go ahead and identify sine, cosine, and tangent. Then we'll get the reciprocals and get the other three. Okay, so the first thing to note is the x value is negative square root of 3 over 2. So that's going to go as our cosine. The y value is 1/2, so that can go as our sine. And then remember, tangent is sine over cosine. So just kind of filling that in. We just wrote sine over cosine. Now our goal is let's reduce this down a little bit. We don't want to leave this as a fraction over another fraction. So I think on this one, the easiest way to do that is I'm going to multiply numerator and denominator both by 2. It's like multiplying by 1 here, but why I'm doing that is I want to get rid of these little denominators of the small fractions inside. So when I do 1/2 multiplied by 2 for that big numerator, I'm going to get a 1. And then for our denominator, I can say, well, 2 and then multiplying by 2 and then multiplying by something over 2, that creates a 1 as well. So we get negative square root of 3. So at least we got rid of our fractions within fractions. We may choose to go one step further here and go ahead and clean up getting rid of radicals from the denominator. So a process we refer to as rationalizing the denominator. To do that, I would multiply numerator and denominator each by the square root of 3. So that's going to leave us with 1 times the square root of 3 is square root of 3 in our numerator. And then we have a negative in our denominator, but we have square root of 3 times square root of 3, which is square root of 9, which turns out just being 3. So our overall answer is the negative square root of 3 over 3 for the tangent of t. All right, from here, the rest of it really is we want to do a little bit of work and get these other three. But since we got the first three, sine, cosine, and tangent, really what we need to do is we need to use the reciprocal identities and remember that a c and an s go hand in hand when we're thinking about which ones pair up. All right, so when sine is 1 over 2, cosecant is going to be 2 over 1. Or with a little reducing down, we can say that's the same thing as 2. Again, we can pair up an s and a c, so cosine and secant go hand in hand. As we invert that, we get 2 over the negative square root of 3. We may want to, again, rationalize the denominator by multiplying numerator and denominator each by the square root of 3. So this is going to be 2 square root of 3. And with a very similar computation, we do square root of 3 times square root of 3 makes square root of 9, which will reduce down to 3. And let's not forget our negative. I'm just putting it out in front of the whole thing instead of in the denominator. Last one to get cotangent of t. I'm going to use this version where we had 1 over negative square root of 3. As I invert that, flip that upside down, use its reciprocal, that's going to be the negative square root of 3 over 1, which will reduce down to negative square root of 3. All right, hope that one helps. Let's do one more of these real quickly where we're given another terminal point. We're given the square root of 2 over 2, comma, negative square root of 2 over 2. Now this happens to be in the fourth quadrant as it's been graphed down here, but don't get too thrown off by that. The x value is square root of 2 over 2, so that's going to correspond with cosine. The y value is negative square root of 2 over 2. So that's going to go as our sine value. And then tangent, remember, is sine all over cosine. So sine over cosine produces negative square root of 2 over 2, all divided by square root of 2 over 2. Same thing, numerator and denominator, so that's going to work out to be negative 1. All right, now that we have those three, let's work on getting cosecant, secant, and cotangent. So again, cosecant goes hand in hand with sine, but remember you invert it or take its reciprocal. So negative 2 over the square root of 2. And then to rationalize, I'm going to go ahead and multiply numerator and denominator both by the square root of 2. So that gives us negative 2 square root of 2 for our numerator. And then square root of 2 times square root of 2 makes square root of 4, which reduces down just to be 2. So overall, what's going to happen here is I think we end up getting the 2's get to cancel out, numerator and denominator, and we're going to have negative square root of 2. All right. For secant, that goes hand in hand with cosine. So very, very similar process here. We just invert it, use its reciprocal, 2 over the square root of 2. As I multiply numerator and denominator by the square root of 2, again, we get 2 square root of 2 all over 2, which will work out just to be the square root of 2. Things are moving very slowly here on my screen. All right, the very last one here, cotangent of t. You can visualize this as negative 1 over 1 if that helps. As you invert that, take its reciprocal, it's 1 over negative 1, which works out just to be negative 1 with a little bit of reducing down. All right, so I would suggest whenever you're given a terminal point, locate the x value is going to be cosine, y value is going to be sine. Remember, tangent is sine over cosine, set that up, and then take the reciprocals to get these other three. All right, hope this helps out. Good luck with terminal points and coming up with all 6 trigonometric ratios. Good luck.